Alright, for number 11, we have an object that is thrown with a velocity of 28 meters per second at a angle of 36 degrees to the horizontal. So the first thing you want to do is start by drawing a picture. You have a horizontal, and we have a velocity where this is 36 degrees and this is 28 meters per second. So if this thing's thrown on this velocity, then it's going to travel up on that velocity and eventually land somewhere on the ground over here. And what you're asked to find out in this question is what is d, where the d is the distance between where it began and where it fell on the ground. So first thing we need to do here is to split this 28 meters per second, this vector, into its horizontal and vertical components. Well, the vertical component is going to be opposite, so it will be 28 meters per second times the sine of 36, while the horizontal will be 28 times the cosine of 36. And you'll take these values and you'll do both vertical and horizontal kinematics with them. So, vertical and horizontal. So initially start by writing your variables, VF, VI, D, A, and T, and again, VI, VF, D, A, and T. So we'll start with the vertical. Your initial vertical velocity was 28 times the sine of 36. Let me type that into a calculator right quick, and let's figure out exactly what that value is. That's going to be 28 sine 36. That's not right. And this is in radians. Alright. 36 sine times 28. Alright. So this right here is going to be equal to 16 point, let's call that 16.5 meters per second. It's really 16.45, but whatever. We'll call it 16.5. Our final velocity we don't know yet, but we do know our vertical distance. Since we begin and end on the same horizontal, we can say that this distance right here is 0 meters per second, and that our gravity is going to be negative 9.8 meters per second squared. Now we say this is negative because we have to set positive directions. I'm going to set up and to the right to be positive here. And we're looking for our time, because our time in the vertical direction will be the same as our time in our horizontal direction. Now our initial velocity in our horizontal will be 28 cosine of 36. And again, we can type that into a calculator. 36 cosine times 28. And that's going to be 22.7 meters per second. Our final velocity will be the same because our acceleration is 0 meters per second, because the only thing we have acting on this is gravity, and gravity goes down. And we're looking for our distances right there. So let's go and figure out what this time right here is first, so that we can figure out this for our horizontal velocity. Now, we have our initial velocity, our distance, and our acceleration. So we can use our formula that says d equals VIT plus 1/2 AT squared, where our distance was 0 meters. Our initial velocity was 16.5 meters per second. We're looking for time, so plus 1/2 and 9.8 meters per second squared times t squared. So the first thing we want to do is subtract one of these sides from, to get one of this, either this side or this side to the other side. So I can subtract the 16.5 and then multiply everything by negative 1. Basically gets rid of this negative sign on this 9.8 here. So 16.5 t equals 1/2 times 9.8 is going to be 4.9. So that's going to be 4.9 t squared. I can cancel out this t and that squared right there, which gives me that t equals 16.5 over 4.9. And then if we solve that, 16.5 divided by 4.9, that's going to be that t is 3.36 seconds. So I can go over back to this last slide, and I can enter in 3.36 seconds there. which means this horizontal is also going to be 3.36 seconds. Because it's in the air for the same amount of time in the vertical as in the horizontal. So now that we know this horizontal time, let's go and figure out this horizontal distance. Now the key to this problem here is that your acceleration is going to be 0. And you should know that if your acceleration is 0, then you can go to the formula d equals VIT. Now really this is d equals VIT plus 1/2 AT squared, but if a is 0 here, then everything here cancels out. Because 1/2 0 t squared is 0. So our distance is what we're looking for. We know our velocity in the horizontal is going to be 22.7. So let's plug in 22.7 meters per second there. And we know our time is going to be 3.36 because we determined that there. So 22.7 times 3.36. Plug it into your calculator. And we find distance of, I have this right here, is 76.3 meters. Now I rounded a bit here, so if you're anywhere around 76, anywhere from 76 to 80, you probably did this the right way.